Okay, we're going to talk about this couple of these practice problems from the introduction. I'm doing the sum array method, which accepts an array of floats. Okay, so I'm going to call it x as the parameter here. So basically, a method is designed. You can see I'm doing it for first and second. It should work for both of these, right? So, but first gets passed to the parameter here, and it becomes x inside this method, and then second gets passed to the parameter here, and it becomes x. So in general, I'm coding how to sum an array called x. Okay. So the way that we can run this is I can iterate through. Iterate just means to loop through the values, and you got to know that the indexes, which indices is plural, the indices for the array start at 0. So I'm going to start I is going to be the index of the array. So this would be index 0, index 1, index 2, index 3, 4, and 5. Okay, and I'm going to say as long as I is less than x dot length, and then I'm going to add 1 to I. Remember, look back at the for loop there of how to write an appropriate for loop. So one thing to realize here is that the length of this array would be 6. There are 6 numbers. The indices would be 0, 1, 2, 3, 4, and 5. The last index is 5 because they start at 0. So if I do a strict less than the length, if x dot length would be, like, for example, 6 for this first example, then this for loop will iterate when I is 0, I is 1, I is 2, I is 3, I is 4, and I is 5. So it'll catch all the values. And all I'm going to do here is I'm going to take the old, and remember, right side gets assigned to the left side here. So it's the right side is sum plus xi. And understand what xi is. It's just each, this needs to be a float because I'm actually adding up the float values. These can be decimals as well, not just ints. Okay, so x of I is just the value of the array at the index I. That's the notation there. So let me look at just second when second gets passed here. X of 0 would be 1. So sum, which started off to be 0, which becomes sum plus 1, which would become 1. And then I goes to 1. So then sum plus x of 1 is 2. So we're going to add 2 to the current sum, which is 1. So now this is 3. Right, and then we assign it back to sum. Remember, right side assigns to the left side. So it's just going to add the current value to the sum every time. So we should get the sum, and then I'm going to return that sum. So that is, it should be the sum of the arrays. I'm not going to do the first one in my head, but 3, 6, 10. This should be 15 for the second one. Okay, and I can run it here. 15, and then 35.9 seems pretty reasonable for the first array. Okay? All right, so we got another one. All right, so number 2, I'm looking at this document. I'm just pulling them up. Grade quiz. Boolean responses. Boolean, it should accept 2 array of Booleans. The first array consists of the answers given by a quiz taker, and the second array consists of the correct answers. The quiz was all true-false questions. You can assume that the Boolean arrays have the same length. It should return the proportion of questions answered correctly, so it should be a float. Should return a float. Okay, or a double, but let's just do floats. All right, so I'm going to put this in setup. I'm just going to paste the whole thing, actually. Okay, so the method that I'm doing here is public float grade quiz, and it's going to be a Boolean array. I'll call it A, well, yeah, it doesn't matter. Boolean B. Okay, I think the way that I did it was like answers and key. Let's do that. Answers and key. Okay, so similar to the last problem. Oh, I can't do key. Answer key. Okay, so similar to the last problem, I'm going to count. I'm going to have like a summer or a counter before the for loop. I'm going to iterate through both the answers and check to see when they're the same, right? Because really what I'm trying to figure out, there's too much space here. But when these two are the same, that means the answer and the answer key are the same. Okay, so I'll say int correct 0, and I will iterate through. So same thing with this array. The first index will be 0. So how many ever, and they're guaranteed to have the same length. All right, we're assuming that. And as long as I is less than, I could do answers.length, or I could do answer key.length because it's the same thing. Okay. I++. Okay, and then I'm going to reference answers of I, and I'm going to reference answer key of I. And I'm going to see if they're the same thing. Because if answers of I, which would be, true, false, true, true, false, false, for all those values, and I'll check it against the same index of answer key of I. Okay? And if they are the same thing, I don't need this brace, but I'm going to do it just to get in the habit of this. And I'm even going to do this. Okay. So if that's true, I'm going to add 1 to correct. This is the same thing as correct plus 1. This is the shorthand for that. This is what I++ means, right? I'm adding 1 to I. Here I'm just adding 1 to correct. So how many ever times that happens as I iterate through those arrays, that's what correct is going to be. Okay, and then let's see. You can, if you highlight one of these braces, it kind of tells you where you are. So out of this for loop, which means it has iterated through all of the answers. All right, correct is how many we got right, and then the length of either one of these arrays would be how many questions there were. So I got to be careful not to do what's called integer division. Like if I did, I'll just show you, print ln 5 divided by 2. We would think that this would be 2.5. But what actually happens with two ints is that it just truncates the decimal. It just chops off the decimal place. So it's just going to give me 2. So in this case, like if I got 5 right out of 12 questions, that's just going to be 0. Right? So I don't want 0. I want the decimal of how many I got right here. So what I'm going to do is, there's several ways to do it, but I'm going to return 1.0 times correct divided by answers.length. Now what happens, and another way to correct this is I could have just made the correct variable here a float. Okay, but I made it an int, so what I'm doing here is multiplying it by 1.0, which becomes a float or a decimal value, and then whenever you divide a decimal, let's call it float, double, something like that, by an integer, you're going to get a decimal. Okay, so, and I gave you the comment here that says should be 0.6. We got 6 out of the 10 questions correctly. Let's see what happens here. Yeah, so we got 0.6. So you'd have gotten a 60 on that quiz, or 60 where they were the same. All right, let's go to 3. Let's see how many there are here. 5. Okay, I'll do one more here, and then I'll do 4 and 5 in another video. So calculate pay. All right, calculate pay takes in a number of hours and a rate. The method accepts 2 floats, the number of hours worked and the pay rate in dollars per hour. the method should return the amount to be paid to the employee. However, if the worker works over 40 hours, then all hours over 40 are paid as time and a half. This means the rate for these hours is 1.5 times as large as the normal pay rate. Okay, so let me try this. Calculate pay, public float, calculate pay, float hours, float, I'll call it rate, which is in dollars, by the way. Dollars and cents. So this would be $10.50 an hour. This would be $8 an hour. Okay, so really there's two cases. Anything after 40 hours gets taxed at or gets paid at 1.5 times the rate. Okay, so we really have two cases. Did you make over 40 hours? Because if you didn't make over 40 hours, then you can just give back hours times the rate. It's pretty simple, right? So 30 times 10.5, that's going to be how much you make if you work 30 hours a week at $10.50 an hour. Okay, and so let's take care of that first. If hours is less than or equal to 40, return hours times rate. Simple. Okay, now the other case is if we make more than 40 hours. So by the way, the return actually stops a method, meaning I don't even really need an else case here, because if the compiler makes it to this point in the code, then that means hours was not less than or equal to 40, because it would have already gave back the answer and stopped. Okay, I'm going to use the else case again, even though I don't need it. Just some of us are going to, so you're new to this and it might seem a little different. So this is saying, okay, hours is greater than 40. So what I'm going to do first is I'm going to create float leftover, which is going to be hours minus 40. Okay, so that's how many hours more than 40 hours we worked. Okay, that's the one that gets paid at 1.5 times the rate. And then the first 40 hours get taxed, or not taxed, gets paid at the rate. So I can really return, it'll be 40 times rate plus leftover times 1.5 times the rate. All right, so this is how many hours we worked over overtime, or over 40 hours. Get 1.5 times rate, so this will get $12 an hour. That's what that's saying. I dropped the L there. So $12 an hour for the 5 hours left over here, right? Okay, so if we get that, it should print 315 and 380. 315 and 380. Okay, all right, I'll stop that, and then I'll do videos 4 and 5, or problems 4 and 5 on the next video.